So number one was just a question on function transformations, which I've written on the right-hand side here. I hate to say it, but I mean, this is one of those things where you just have to know the function transformations. It's not really something you can figure out. So just a quick refresher. What function transformations say is, for any given function, if you add something to the whole function, you'll shift the graph up. If you subtract something from the function, you shift the graph down. However, if you add directly inside to the x, so you're not adding to the whole function, but you're adding straight to the x, you'll actually shift the graph to the left, whereas if you subtract directly from the x, you move the graph to the right. Now, if you multiply a function by a number, what happens depends on what that number is. If that number is bigger than 1, you're going to scale the graph vertically. What that means is, for any graph, in our case, it's an absolute value, so it looks like a V. If I multiply by a number that's bigger than 1, what it does is it sort of like stretches the graph vertically up. So it looks narrower, looks skinnier. So that's what this highlighted line means. Now, if the number that you're multiplying is smaller than 1, but still positive, it will do the exact opposite. It'll vertically shrink your graph. So for any given graph, again, ours is an absolute value, what it does is it sort of flattens out the graph vertically and makes it wider because you're literally making all the y values smaller. And if you multiply by a number that's negative, what it does is it reflects the graph over the x-axis, or in other words, it flips it upside down. So for number one, you just had to be able to read the function transformations. So they gave you negative f of x minus 1 plus 2. Hopefully we can read that the minus 1 tells us to go right 1, the plus 2 tells us to go up 2, and multiplying by the negative on the outside tells us to flip upside down. Now, if this is our original graph here, well, there's only one graph that has these characteristics. Shift to the right 1, move up 2, flip upside down. That has to be graph B. So that was the answer for number 1. Number 2, all I had to do was read the story and write the equation. I didn't ask you to solve or anything. So it's just practicing if we can read and extract information. The story goes: the grocery store has kumquats that sell for $4.75 a pound and Asian pears that sell for $2.50 a pound. Write an equation that represents how much of each type of fruit can be bought with $20. So let's extract the information they give us. So they tell us that kumquats sell for $4.75 a pound, so that's one type of information. Asian pears sell for $2.50 a pound, another type of information, and they give us a total of $20. So I hope we can recognize that there are actually two different items here, kumquats and Asian pears. So two different items, they're going to be two different variables. I don't care what letter you use. You can use K and P's. I'll just stick with the standard X's and Y's. And hopefully we can see that the information, numerical information, $4.75 a pound relates to the kumquats. So $4.75 times the number of pounds of kumquats plus $2.50 a pound times the number of pounds of Asian pears should equal the $20 that I spent. Now, I did see some people on the exam use a less than or equal to inequality. I mean, technically the question says equation, but I gave you full credit for using these inequalities because I suppose I don't have to spend all $20. So if you use any of these three symbols here, I give you full credit. Number 3 looks like it's a scary looking problem. It gives you a big, ginormous equation here. But notice how it also gives you numbers, right? Numbers for the variables. So this was actually, it was a lot scarier than it really is. If they give you a formula or an equation, but then they give you numbers for those variables, all I gotta do is plug it in. So let's do it. So I'm going to rewrite the equation. S equals 2LW plus 2LH plus 2WH. And according to the problem, again, wherever I see an L, I'm going to substitute a 10 inches. Wherever I see a W, he's going to become a 7, and wherever I see an S, he's going to be a 276. So let's do the substitution. So 276 equals 2L was 10, W was 7, plus 2L was 10, or no, L was 10, plus 2W was 7. Notice I left the H's as variables because they did not give me any H's, so just keep them as variables. And as a matter of fact, that's what the question is asking us to find. It's asking us to find the value of H. So notice just say regular equation, so just do math. 276 equals 2 times 10 times 7 is 140, plus 2 times 10 is 20 H's, plus 2 times 7 is 14 H's. Let's combine like terms. 20H plus 14 H's is 34 H's. Subtract the 140, so that's 136 equals 34 H's, and then divide out the 34. That gives you H is 4, so the height is 4 inches. Number 4 was a function transformation question, and again, this is sort of a you have to know it or you don't know it kind of thing. These function transformations, you can't really figure them out. You have to know how each part of the equation affects the overall graph. So they give us y equals 7 times the original function minus 3, and if you know your function transformation, it should just be a matter of reading. So this would be a vertical scale by a factor of 7, and then this, because it's on the outside of the function, is simply down 3. So there really wasn't anything crazy about this problem. You just had to be able to read it, and the answer was, of course, D. Number 5, it gives you information about specific number of CD players sold per specific year, and they ask you to find the average rate of change of sales between 1989 and 1999, or 1989 and 1999. And as I said in class, I'm sort of giving you a hint here. Rate of change, it just means slope. So they want to find the slope of the change in sales between 1989, which is right here, and 1999. Okay. So when they make a relation between these two numbers, they're really making a coordinates. So I can sort of think of this as 1989, comma 545. I think these are millions. It doesn't say. And I can link 1999 with 695. And then since I want the rate of change, aka slope, just find the slope between these two guys. We have to remember that slope is y2 minus y1 over x sub 2 minus x sub 1. It really doesn't matter which point I designate as the first point and the second point. Let's call this x1, y1, and let's call this x2, y2. And then all it is just plugging the numbers in. y2 is 695 minus y sub 1 is 545 over x sub 2 is 1999 minus x sub 1 is 1989. So that is going to be 150 over 10. So the average rate of change is 15 CDs per year. I'm not sure if it's CDs or millions of CDs, but the average rate of change is 15. Number 6 is a proportional equation, and we have to remember that if you hear or read the word direct, it's going to be whatever the variables are, they're going to be in the same level of the equation. But if your proportion or variation is inverse, your variables are going to be opposites of each other. One will be in the numerator and the other will be in the denominator. Regardless of what proportion you have, you always start off the same. Variable equals k, because every single proportion question has a constant proportionality k. So let's read this. What are the players involved? The cost C of printing a magazine is jointly proportional. So the moment I read that word, jointly proportional, inversely proportional, directly proportional, I'm going to put the letter, the variable, equals k. So we're talking about the cost equals k. Now I have to figure out, okay, what are the players involved? We have number of pages P, I'll use a different color. Number of pages P, and the number of magazines to be printed M. So, since it's jointly proportional, jointly just means more than one direct, they all go on the same level. So P and M go all on the same level. Now they give me numerical information. Well, what information do they give me? They give me 6,000 copies of a 130-page magazine, and it costs 156,000. So all you got to do is put the variables in the right spot. To print 6,000 copies, hopefully you can agree that that's the number of magazines to be printed. 130-page magazine, well, that's the number of pages, and obviously 156,000 is the total cost. So you plug all those pieces of information in, it should allow you to solve for the constant proportionality. So 156,000 equals K, number of pages is 130, and the number of copies is 6,000. Then all you got to do is break out a calculator and do math. So let me bring up a calculator here. So 130 times 6,000, that's 156,000 equals, that's going to be 780,000. And then to solve for K, you divide both sides by 780,000. So that gives you 0.2 equals K. So all of this work gives me what I call a complete equation. So my complete equation is C equals 0.2 PM. A complete equation is the original proportional equation with everything as variables except for K. Now notice they give you new information. 2,000 copies. I reused that color. They gave us 2,000 copies and 94-page magazine. So that right there, number of copies, that's M. I'll use a pencil. That's M. And 94 pages is obviously number of pages. And it's looking for cost. So you take this new information, plug into your complete equation to finally answer the question. Cost equals 0.2. Number of pages is 94. Number of copies is 2,000. Notice they're all numbers, so you just go ahead and pop that into your calculator, and you get your answer of 37,600. So that was the answer. So these proportional equations set up the proportion. If they give you numerical information, plug that numerical information in to solve for K. And then it'll give you a complete equation, and then if they give you more numerical information, plug that information in and solve for whatever letter they're asking you to solve for. Number 7, another proportion problem. In this case, they only give me one set of information, so it looks like once I get the complete equation, I'm done. So let's read it. What are the players involved? H is jointly proportional, so immediately I know it's H equals K. So what are my players? Squares of L and W. So you have to know it says squares. That means an exponent of 2. So here's the square of L, and here's the square of W. And then all I got to do is plug in the information, right? They give you L equals 4, W equals 1/5, H equals 48. Plug all that piece of information in. H is 48, L is 4, W is 1/5, and then you just do math. So that's 48 equals 4 squared is 16, 1/5 squared is 25, so that's 16 over 25K. And this one I'll actually show to get rid of a fractional coefficient. You go ahead and multiply by the reciprocal. Right. So that gives me K equals 75. So there's your complete equation. H equals 75, L squared, W squared. And since they did not give you a second set of information, that's all you can do. They just wanted the equation. There's our equation. Number 8, I give you a graph, and I ask you to find the average rate of change between the 2 points indicated. So it's just asking for slope. There are 2 ways you could have done this. You could have read the points, so hopefully you could read that this is 1, 0, and this is 4 comma 3, and then you just use the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and then just plug in the points. It doesn't matter which one you call it. Let's call this x1, y1, and x2, y2, really doesn't matter. Y2 is 3, minus y1 is 0, over x sub 2 is 4, minus x sub 1 is 1. So that gives you 3 over 3, which equals 1. Right? Easy peasy. Or, and this is the way I would have done it, since they give you a graph, just, count, right? Slope is rise over run. So from this point to this point, how far up or down do you have to go? Clearly, you go up 3, and what's your run? My run is a positive 3. So rise over run, 3 over 3, that's 1. Right? So either way, the slope was 1. Number 9 is writing an equation problem. Now, there are lots of layers to this question. When it comes to writing a linear equation, what you want is a slope and a point. Right? So if you read this question, find an equation line that satisfies the given condition through -1 comma -11. Well, they give me a point, and perpendicular to the line passing through 3 comma 1 and 7 comma -1. Nowhere in this information does it say your slope is blah 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 blah. So they don't give us a slope. That tells you we have to go find it. Now the only information they give you is that it's perpendicular. So this is another layer that we need to know. We need to know perpendicular implies opposite reciprocal slopes. So the slope we're going to use will be the opposite reciprocal to this information. And the only information they give us are these 2 points. They're not the points that we're going to use on our line, but it will be points that we're going to use to find the slope. Well, gee whiz, I have 2 points. I need a slope. This is a clear application of the slope formula. Again, it doesn't matter which one you designate as 1 and 2. I'll just go in order. And then once more, slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Just plug stuff in. Y sub 2 is -1 minus y sub 1 is 1 over x sub 2 is 7 minus x sub 1 is 3. So that gives you a -2 over 4, which is -1/2. Now the question said perpendicular, so we have to remember that perpendicular means opposite reciprocal slope. So all of this work says is that their slope is -1/2. We want perpendicular, which means opposite and reciprocal. So that means our slope has to be the opposite reciprocal of it, or in other words, a positive 2 over 1, or simply just 2. So there we go. We have our slope. We have the point that we are going to use. Again, I'm not going to use these points. These points are done. They're not my point that I want to go through. I want to go through this point here, the one I highlighted. So use that point, use our slope that we found to write an equation of a line. You can use slope-intercept form, y equals mx plus b, or what I showed in our notes and in our lessons is point-slope form. So that's what I'll show in this solution. Y minus y sub 1 equals m times x minus x sub 1. If you want to use y equals mx plus b, you should get the same answer in the end. So y minus the y variable of my point is -11 equals my slope is a positive 2, x minus my x variable of my point is -1. You got minus a negative here, so that's y plus 11 equals distribute. 2 times x is 2x. And then right here we have a minus a negative, so that becomes a positive 1. So 2 times a positive 1 is a positive 2. You minus 11 on both sides, and you get y equals 2x minus 9. That should have been the equation. Number 10, which graph does not represent a function? So if I ask you about whether or not something's a function and I give you a graph, the idea is to use the vertical line test. The vertical line test states, graphically, something is a function if, no matter how you slice it vertically, you'll only intersect the graph at most one point. So hopefully we can see that letter C is a function because no matter where I slice it, every single slice only touches 1 point. So that slice only touches once. This slice only touches once. That slice will only touch once if I extended the graph. So no matter where I slice it, C is a function. Going through that logic, the only graph that fails that test should be graph A. Because if you notice, if I make this slice here, hey, this one touches the graph in 2 spots more than once. So by the vertical line test, it is not a function. So the answer should be graph A. Number 11, again, it was just knowing what parallel perpendicular meant in terms of slope. To refresh our memories, parallel implies that the slopes are the same, and perpendicular implies the slopes are opposite and reciprocal. If the slopes are not any of these guys, then it's just neither. So let's do the slope of number 1. Since they gave us 2 points, and we want to analyze slopes, this is an application of the slope formula again. So to refresh your memories, the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's do the slope formula for line 1, and let's just make the x1, y1, x sub 2, y sub 2. Let's just make it easy, go in order. So for line 1, y sub 2 is 0 minus y sub 1 is 5 over x sub 2 is 2 minus x sub 1 is negative 3. And then you just do math. So that gives you, what, negative 5 over a 5, which gives you a negative 1. Do the slope formula for line 2. We're going to use these sets of points here. So y sub 2 for line 2 is 3 minus y sub 1 is negative 3. All over x sub 2 is negative 1 minus x sub 1 is a 1. So that gives you a 6 over negative 2, which equals negative 3. They are not the same. They are not opposite reciprocals of each other. So these two lines that contain their separate points, they're nothing special to each other. They're neither. They just intersect regularly. So they're not parallel, nor are they perpendicular. Number 12, again, I give you a graph and ask you to find the slope. You could use the slope formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and that requires you to be able to know what the points are. So just by looking at the graph, we can see that the coordinates of these points are negative 4, 3, and 0, 1, 2, 3, 4, 5, right? And then just plug it in, get your slope. What I prefer to do if I have a graph is I just like to just read it, right? Can't we just do rise over run by looking at the graph? So looking at the graph here, how far do we rise? Well, actually, this should be a negative 3, by the way, negative 3. We rise 8. How far do we run? 4, right? So if slope is rise over run, right? Slope is rise over run. We rose 8 units in the positive direction, and we ran 4 units in the positive direction, so the slope is 2. You would have gotten the same answer if you used the formula, but with the graph, I just like to count. Number 13, write an equation of a line. As we said in our lesson, when it comes to writing an equation of a line, I don't care what the context is, I don't care what class it is, we always need the same two pieces of information. We need a slope and we need a point. So if you read the story, it says write an equation for the line passing through the point, this guy. So they give me a point, and parallel to the line x plus 5y equals 5. Now, nowhere in this sentence does it say your slope is this. So it does not give us a slope. That means we actually have to do extra work to find it. Now, the only extra information they give us is parallel to this line here. So we have to remember that parallel in terms of slopes means same slopes. So I know that the slope we're going to need, the information we're going to need, is going to be the same as the slope here. Now, the equation that they gave us is in standard form, and I can't read slope in standard form. So before you do anything, you got to solve for y, get it in slope-intercept form. So hopefully this is really quick. Let's subtract x from both sides. That gives you 5y equals negative x plus 5, and then we're going to divide everything by 5. Hopefully you all remember that if the coefficient is not visible, there's always a 1 here. So that means this equation is y equals negative 1/5 x plus 1. And hopefully it's easy to see now that their slope is negative 1/5. Now this is where the thinking has to come into play. So their slope, just by reading it, is negative 1/5. We want parallel, which means the same slope. So that means our slope is also going to be negative 1/5. That is the only thing I'm going to extract or use from this work. That's the only thing I'm going to extract or use from this equation. So now that I have my slope, I am done with this guy. A common mistake I saw in the test is people want to use it some more. So no, we have a slope now. We have a point now. Use those information to write an equation of a line. Now, some people like to use y equals mx plus b, and that's okay, but in class, in our lesson, I use point slope form, and that's what I'll show in the solution. Y minus y sub 1 equals m times x minus x sub 1. If you like y equals mx plus b, go ahead and use it. You should get the same answer. So y minus the y value of our point is negative 4 equals our m is negative 1/5 times x minus our x value is 5. So y minus a negative 4 minus a negative is a positive. And then we'll go ahead and distribute the slope of negative 1/5. Negative 1/5 times x is a negative 1/5 x. And negative 1/5 times a negative 5. Negative times a negative is a positive. And 1/5 of 5 is a 1. Go ahead and subtract 4 from both sides, and you get the equation. Y equals negative 1/5 x minus 3. That is the equation, the line that goes through this point and is guaranteed to be parallel to that line. Okay. Number 14 was a function transformation question, which I have here on the right. And when it comes to function transformations, it's you either know it or you don't know it. There's really not much you can do to figure out. So hopefully we can see that in this notation here, the transformation is present. If you minus 1 directly to the x, it goes to the right. So this is a right 1, and a minus 5 on the outside goes down 5. Well, how do I actually do a transformation of a graph? Well, if they give me the original graph, which they have here, you literally do these transformations. So what I'm going to do is I'm going to take all of these points here, because those are sort of like the key points there, and just do the transformations. I'm going to move down 5 and right 1 for every single point. It doesn't matter the order. So let's do this point here, the one I'm highlighting. So I'm going to go right 1 and then down 5. 1, 2, 3, 4, 5. That is the new location. Let's do this point right here. Go right 1 and down 5. So 1, 2, 3, 4, 5. That is his new location. Let's do this point here. Go right 1. Here we go. And then down 5. 1, 2, 3, 4, 5. Right there. And let's do this last point. Come on, erase. There you go. Let's do this last point here. Right 1. There you go. And down 5. 1, 2, 3, 4. There's his new location. And then since I knew they were line segments, you just connect the dots. So that should have been the graph of the function transformed. Number 5, write an equation of a line that passes through the point 1, comma, negative 3 and is parallel to this line here. So as said in class, when it comes to writing an equation of a line, I don't care what the story is, I don't care what class you're in, Algebra 1, Pre-Calculus, Calculus, and beyond, to write a linear equation, you need a slope and you need a point. Hopefully you can read this, that they give us a point, we want to go through here, but nowhere in the story does it say your slope is this. So they do not give us a slope. Well, the only information they give us is it's parallel. So we have to remember that parallel means same slope. So when we go on our hunt for a slope, I know it has to have the same slope as this line. Well, since they give us the equation in slope-intercept form, there's not a lot of work done. We can just look at it. We know that their slope is 4, just by reading. Well, since we want a parallel line, the idea is parallel lines will have the same slope. That means our slope is also going to be 4. That is the only thing I want from this equation here. From this equation or that equation is his slope, which we've already done. So I'm done with him. Right? We don't need this information anymore. A common mistake I saw was students are really trying to use this equation, but the only information I needed was the slope, which we now got. So now we have a slope. This slope here. We have a point. This point here. Just write the equation now. Some people like y equals mx plus b. I like point slope form. That's what I showed in class. That's what I showed in notes. So that's what I'll show in the solution. But if you use y equals mx plus b, you should get the same final answer as me here. So slope-intercept form, or excuse me, point slope form is y minus y sub 1 equals m times x minus x sub 1. Just plug everything in. Y minus my y value of my point is negative 3 equals the slope was 4, x minus our x value is a 1. Go ahead and simplify. Y minus a negative 3 minus a negative is a positive. Distribute the 4, that's a 4x minus 4, and then subtract 3 from both sides. Y equals 4x minus 7. That should have been the equation. Number 17, which graph does not represent a function? So this is a question testing your understanding of the vertical line test. The vertical line test states that if I give you a graph and I want to know whether or not it's a function, what you have to do is to test it, just slice it vertically up and down. And if you can keep slicing this up and down, no matter where you slice it, if every single slice only touches the graph at most one time, it is a function. So for example, letter A is a function because no matter where I slice it vertically, say I slice it here, oh, it only touches once. What if I slice it here? Oh, it only touches once. What if I slice it here? Oh, it only touches once. So no matter where I slice it, I will only touch it once. So graph A is a function. So go through that same logic for all these graphs, and hopefully you'll see that graph D is not a function, because if I slice it, say here, it touches actually 3 times. And that, by the rule, means it's not a function. So graph D is not a function. Number 18 is a variation or proportion question. The idea is, if you read those words, varies, proportions, whatever, there are 2 types. If you have something like y is directly proportional, varies directly to x, that'll produce an equation that looks something like this. Notice that the 2 variables are on the same level. There's no fractions, or if there were fractions, they're both in the numerators. But if you read something that says inversely, varies inversely, directly, inversely proportional, doesn't matter, that means the 2 variables are going to be on opposite levels of the equation. Notice that the y is in the numerator and the x is in the denominator. So direct variation, the 2 variables you're comparing are on the same level of the equation. Inversely proportional, inverse variations, the 2 variables you're comparing are on opposite sides of the equations in terms of the fraction. Notice that no matter what variation you have, you always start off the same. Variable equals k. So there will always be a constant proportionalities to proportional equations. So let's do this. So let's read it. It says P varies inversely. Well, the moment, I'm going to stop reading. The moment I hear those trigger words, I'm going to write variable equals k. Now, since it says inversely, I know I'm going to have a fraction. So then let's see what the players are. Inversely SQ. So there we go. Easy peasy. Now notice they give us numerical information. It says P is 10, q is 3/2. So they also do give us q is 3/5 here. So anytime they give you duplicate informations, hey, p is this, q is that, and then they give you another set, typically that means the first set of information will be used to solve for k. A second set of information will be the actual question. So let's plug in the first set of information here. So I know that p is 10. They did not give me k, and then q they said was 3/2. So to solve for k, you want to get rid of the fractions. I'm going to multiply both sides by 3/2. That gives you k is 15. Now you have what I call a complete equation. The complete equation is plugging your k value back into the proportion equation while keeping everything else as variables. Right? Now that you have your complete equation, we can actually answer the question because they give you more information. Here's the second part here. Specifically, they give you q is 3/5. So I'm going to plug in the 3/5. P equals 15 over 3/5, and notice it now gives me an equation to solve for p. Well, hopefully you recognize, or you can probably just use a calculator if you don't like fractions, but here I'm dividing 15 by a fraction, and we should remember from middle school that when you divide by a fraction, that's the same thing as multiplying by the reciprocal. So p should have been 25. Number 19, if you read the question, reading, the important key phrase or trigger word is rate of change, and we should remember that rate of change simply means slope. So I'm probably going to have to do something with the slope formula or think in terms of slope. Well, I hope we can read that they link numbers or they link information together. In 1983, they link it with 1.4 parts per million. In 1986, they link it with 2.6 parts per million. So I can sort of put those relations as a point. 1983 links with 1.4 parts per million. 1986 links with 2.6 parts per million. And what do you know? They want the rate of change between exactly those 2 years. So here you go. Slope formula, 2 points. Let's call this x sub 1, y sub 1, and x sub 2, y sub 2. And recall that the slope formula is simply y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So plug stuff in. So y sub 2 is 2.6. Y sub minus y sub 1 is 1.4 over x sub 2 is 1986 minus y sub 1 is, or x sub 1 is 1983. And then you just do math. So 1.6 minus 1.4 is 1.2 over 1986 minus 1983 is 3. So that is going to be 0.4. Now notice none of the answer choices are in decimal form. You should know that 0.4 is a fraction. Is 2/5. So that should have been the answer. Average rate of change, aka slope of the functions. They give you a function and 2 x values. Now if you think about the slope formula here, this is just a slope question. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. They give us a whole bunch of x values. I have plenty of x values. I don't have y values though. Well, gee, they give me a function though. So if I have function and I have x values and I want y values, all I gotta do is plug it in. So let's plug in the x values one at a time. So they give me 144. So what's f of 144? Just plug into the equation. Hopefully that wasn't too hard. That's 12. What's f of 169? So square root of 169. If I know my square root, I think that is 13. Yeah, I think that's 13. What does all this work tell us? That tells us that the x value of 144, comma, relates to the number 12. The x value of 169 relates to the number 13. There you go. There are your 2 points. It's asking for slope, so just do the slope formula. So there's x sub 1, y sub 1, x sub 2, y sub 2, and then just plug it in. So we get m equals y sub 2 is 13 minus y sub 1 is 12 over x sub 2 is 169 minus x sub 1 is 144. Do some math. That's 1 over 25. That's it. That's the slope. Number 21, I give you a finite set of points, and as you find the range, you have to remember that domain is the set of x values, and the range is the set of y values. So since I want the range, I just want the y values here. So it's really that easy. So it's my answer. It's the y value of -3, -2, and 3. I wrote it from least to greatest. If you wrote it in a different order, I give you full credit for it. But it's as simple as that. Number 22 says the following data represents the amount of total amount of cheeseburgers have been sold at a local restaurant throughout the day. Determine the average number of cheeseburgers sold per hour during lunchtime, and they define lunchtime as from 11 a.m. to 2 p.m. So average number per hour, that is keyword, that's code word for slope, average rate of change. Now, the important thing to realize is this table here does not give you individual number of burgers sold, but rather a running total. That's what it says. This data represents the total amount of cheeseburgers. So since they want the average rate of change, aka slope, between 11 a.m. and 2 p.m., I have to find that information in the table. Well, here's 11 a.m. I guess I should make that skinnier. Here's 11 a.m. and here is 2 p.m. So what that means is you can convert that into a point. Now, we have to be careful here because time is, it wraps around itself. After 12 p.m., it goes back to 1. So to do 11,35 and 2,172 would be wrong because, again, time is cyclical. And to do slope, it needs to be a linear scale. So we have to use 24-hour time, military time. So hopefully everyone knows that 2 p.m. is the same thing as 1400s. So this is actually 14,172. And then all it is an application of the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Right? Doesn't matter which one you call x sub 1, y sub 1, x sub 2, y sub 2, as long as you're consistent. So this gives you 172 minus 35 over x sub 2 is 14 minus 11. So 172 minus 35 is 137 over 3. And if you do that division, you get approximately 45.667 burgers per hour, right? So there is your average rate of change. Right? It's just average rate of change, average number per hour. That's just all code word for slope. Number 23 is a graphing of inequality. So all you really needed was the skills to graph a line. So recall that a linear equation, I know I'm going to use an equal sign, but it works the same with inequalities. In slope and intercept form, this is your y-intercept. It's your starting number. And the number in front of the x is your slope. Those are your set of directions. It tells you how far up or down to go over how far left or right you go. So hopefully in this case we can see that we start at the y-intercept of 2. So there we go. And a slope of 2/3 tells us to go up 2 and right 3. So from our starting point of 2, you just go up 2, 1, 2, right 3, 1, 2, 3. So that's where your other point should be. Now, whether or not your line is going to be solid or dotted depends on the inequality. If your inequality is or equals to, it will be solid. Otherwise, it will be dotted. In this example, our inequality is or greater than or equals to, so you'll have a solid line. Now with inequalities, your solutions are half planes. So all it is a matter of reading the inequality. If your inequality is greater than or equals to, right? This is greater than. My handwriting needs to be better. Greater than. That literally means the y value should get bigger. And hopefully we know on a coordinate system, y's get bigger on top, y's get small on the bottom. So since our inequalities is y is greater than, that means all my answers, all my y values, every single point on this line should go up. So that means this shading here should be the correct shading. That is the graph of number 23. Write an equation line that goes through the point 2, 15 is parallel to the x-axis. Now, normally, when it comes to writing a linear equation, normally we would need a point and a slope. However, this one is special because it uses the x-axis, and we should be always conscientious of special lines. Now, what I mean by special lines, I mean lines that are perfectly vertical or perfectly horizontal. If we visualize it, I hope we can tell that the x-axis is a horizontal line. Now we want parallel to it. Well, what type of lines are parallel to horizontal lines? Hopefully you guys know that the answer is another horizontal line. Horizontal is parallel with horizontal. Well, what do equations of horizontal lines look like? Right. Horizontal lines look like y equals a number. Well, if I have to go through this point here, and knowing that this point is an x comma y value, and I know the equation should look like y equals a number, hopefully, it's very easy, the equation of a line that's parallel to the x-axis that has to go through 2, 15 is y equals 15. That was the equation of the line that satisfies these conditions. Number 25, describe the correlation. Notice how this just looks utterly random, right? A whole bunch of random points here. There is no correlation. So there's none or no correlation. Number 26, tell whether or not the following relation is a function. By definition, a relation is a function if and only if every input, those are the x values, has only one output. Those are the y values. So in a table here, notice how the x's do not repeat. So if the x's do not repeat, it is impossible for them to have more than one y value. So it is a function. The answer is yes. If you couldn't see that, you could have also graphed it, made a scatter plot. Now here's 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, and you can see that it passes the vertical line test. Or you could have made a mapping diagram. Here are the x's, here are the y's. My x's are 1, 2, 3, 4, 5, and my y's is just a 2. So 1 relates to 2, 2 relates to 2, 3 relates to 2, 4 relates to 2, 5 relates to 2. Notice how if you focus on the x's, because the definition of a function only cares about the x's, if you focus on the x's, there's only one line going out of every single x value, which means they only have one y value, which is the definition of a function. So this is yes, it is a function. Number 27, function transformation question. When it comes to function transformations, it's sort of a, you either know it or if you don't know it, so I wrote it over here on the right-hand side. This is just reading. So can you spot the function transformations? So going from this function to this function here, hopefully we can see that the only difference was the 1/2 in front and the -5 on the inside. Well, knowing function transformations, a -5 to the x means you go right 5, and multiplying by 1/2, which is smaller than 1, on the outside is a vertical shrink by a half, right? And the only ones that shrinks by a half and goes right 5 is letter C. So that should have been the answer. Number 28, you could have, is asking you which equation represents a scatter plot. You could do, the writing the linear equations problems that we've been doing before, but you can sort of just approximate. If I were to connect the dots, we can see a couple of things. First of all, we know it has a positive slope, right? So since it's a multiple choice question, I can immediately cancel out all the ones with a negative slope. Now, although my line isn't perfect, you notice how the y-intercept is right here? It definitely is positive. So there's only one choice that has a positive slope and a positive y-intercept. That's choice A. Number 9 is a proportional question. And when it comes to proportionality, the trigger words, the key words we're trying to look for is proportional or direct or inversely. So if you read something that says y is directly or jointly or any of those words, the setup is y equals kx. Now if you read the words inversely, y inversely, they could use variations, proportions, doesn't matter, but the key word is inversely. The setup is y equals k over x. So notice that if it's a directly proportional or direct variation problem, the variables in question, they're sort of on the same level in terms of fractions. They're both in the numerator. There's no fraction. So all variables that are directly proportional will sort of be on the same level. Contrast that with inverse proportionalities. Notice if y and x are inverses, one is in the numerator, the y, and the other is in the denominator, the x. Right? So directly proportional, you put the variables on the same level. Inversely proportional, you put the variables on opposite levels in terms of fractions. But I hope you can see that no matter what proportion you have, you always start the same way. Variable, in this case y, equals k. So it doesn't matter if it's directly or inversely, you always have y, or variable, equals k. So let's go ahead and read the story. It says the resistance R of a wire varies directly. I'm not going to stop reading. That's one of those key words there. So I know that I'm automatically going to start with variable, in this case resistance, equals k. So now all I have to do is read what players are involved. Let's see. It varies directly with its length L, and inversely. Hey, that's a new trigger word. That's a new phrase. Well, what is it What is it vary inversely with? The square of the diameter d. So, since it varies directly with L, directly means it's on the same level on top, but inversely, that means it's on the bottom of the square of the diameter d. So that is the setup. Notice how it gives you numerical information. Well, typically that means you're going to plug stuff in and solve for k. So a wire that is 1.4 meters long, 0.005 meters in diameter, and a resistance of 12 ohms. Well, 1.4 meters long, that's clearly a length. Diameter is clearly d. And ohms, even if you don't know what ohms is, it says it's resistance, which is R. So plug everything in. 120 equals k, the length was 1.4, over 0.005 squared. And then you just do math to solve for k. I don't know what 0.005 squared is, but I'm just going to leave it intact for now. So I'm going to multiply both sides by the denominator to get rid of it. And then divide by 1.4. So that's what k is. So all I'm going to do is just pop that guy into my calculator. So I get this really weird decimal number. So let's round, I don't know, 0.00214. Right? The more decimals, obviously, the better. It would be nice if I could get it exact, but we're going to approximate. So let's see, 120. I'm just double checking my math here. 0.005 squared. So now you can build what I call as a complete equation. A complete equation is the original proportionality with everything as variables except for k. For 3L over d squared. Now typically they're going to give you another set of information. Here we can see that they give us same material is 4 meters long and has this diameter. And it asks us to find the resistance. So plug the new information into your complete equation and solve for the variable. 0.2143, the new length is 4, the diameter is 0.009, and then all it is calculator work. Times 4 divided by 0.009 squared. And we get, I should use squiggles because it's an approximation, 105.82 ohms. Now it said round to the nearest integer, that's nearest whole number, so I'm going to round it up to 106 ohms. Okay. Last but not least, number 30, it was just a simple graphing of a linear equation. We have to remember that equations in slope-intercept form y equals mx plus b. The last number is your y-intercept. That's your starting number. And the slope, the number from the x, that tells you how far up or down to go or how far left to right to go. So in this example, I hope we can see that their y-intercept is 3. So we're going to start at the y-intercept of 3. Now the slope here is a -2. Slope, I usually like to think of a fraction, which is the same thing as -2 over 1. So that tells me to go down 2 because it's negative, and right 1 because it's positive. So now I have everything I need to graph this guy. So let's graph. So I'm going to make some tick marks here. I think on the test I printed out a coordinate plane for you. I guess I should have done that here in advance. So my starting y-intercept is a 3, and a slope of -2 tells me to go down 2 and right 1. So there is my new point. And you could repeat this motion down 2, right 1 over and over and over again until you get 3 or 4 points. Make it somewhat accurate. Down 2, over 1. But after that, it's just simply connect the dots. Hopefully better than I did. There you go. That's the graph. That's the equation.